Good morning, students. It is glad to hear that you have been cooperating with the school administration during the lockdown periods, following the lockdown protocols, and attending the online lessons modules. Looking forward to see you soon. So today we will be starting with the new lesson, that is the amines. 6% is going to come during the exam. So amines. First of all, we'll look what are amines. So amines are derivatives. It is derived from ammonia, so therefore it is derivatives of ammonia in which one or more hydrogen have been replaced with the alkyl group. So in ammonia there are three hydrogens. So these hydrogens can be replaced by the alkyl group. So when this hydrogen is replaced by the alkyl group, then it is known as the derivatives of ammonia. And that is the definition of ammonia. Let us look into the classification of amines. Amines are classified into primary amines and aromatic amines. Not primary amines, it is the aliphatic amines. Sorry. So they are classified into aliphatic amines and aromatic amines. So if you look at this concept mapping, amines categorized into aliphatic amines and aromatic amines. Aliphatic because they do not have the ring structure, aromatic because they have the ring structure. So if you look at the examples of the aliphatic amines, you will not see any ring structure present there. So primary amine, under aliphatic amines, this is the nitrogen, ammonia. So ammonia has three hydrogens. So each of these hydrogen can be replaced by the alkyl group. So if you look at the primary amine, in the primary amine, one of the hydrogen is replaced by the methyl group. Therefore, the name is also methylamine. In the next one, that is the secondary amine, you have the two hydrogen. So in the place of two hydrogen, you have the two methyl group. So therefore known as di. Di represents two methyl. So dimethylamine. And in the tertiary amine, the three hydrogen is replaced by the methyl group. So therefore it is known as trimethylamine. And in the aromatic amines, you have the amine in which one of the hydrogen is replaced by the aromatic ring structure. So therefore they are known as the aromatic amine. Example is your phenylamine or aniline. Let us look down into the nomenclature of the amines. So you have three columns. In one column amines, common name, IUPAC name. So you have the, wherever I have put the star mark, they are important from the exam point of view. So you have the methylamine, which also can be written as CH3NH2, and each of these nitrogen will have the lone pair of electrons, which I have not written here. So methylamine, common name, the easy way of writing is just adding the suffix. Suffix is the last word, amine to alkyl group. And in the IUPAC name, you just have to add alkane with the amine. So you'll get alkanamine. E is replaced by the amine. So alkane amine. So you don't find the E here in this sentence. So methylamine can be written as methanamine because it has only one carbon here, methanamine. Now second one is the secondary amine, that is the dimethylamine, because you have the two methyl group. So it can be written as N-methyl methanamine. Then you have the tertiary amine, where there is three methyl group attached to the nitrogen. All the hydrogen is replaced, so known as trimethylamine. IUPAC name will be N-dimethyl methanamine. N is the position of the methyl group, so that's why you have written N here, N here. Then these are not that much important. It will not be frequently asked in the exam as well, so therefore I have not put the star mark. Below one is the ethylamine. Ethylamine is important from exam point of view, so I have put the star mark there. This is the structure of ethylamine with the lone pair of electrons. So as I was mentioning, all the nitrogens in the amine will be having the lone pair of electrons, which will be available for the donation. So this is also the structure of the ethylamine. Common name is ethylamine. IUPAC name is ethanamine. So remember the IUPAC name of the ethylamine. Remember the IUPAC name of the methylamine. Very important. Also, the last one is your aromatic amine. That is aromatic amine. This is from the aromatic amine. This aniline or phenylamine is the primary amine. Remember, this is the primary amine because you have only one ring structure. In your syllabus, you don't have to study about the diphenylamine or triphenylamine. Diphenylamine is a secondary aromatic amine. Triphenylamine is the tertiary aromatic amine. So secondary and tertiary, you don't have to study under the aromatic amine. So you just have to study aniline. Aniline is the example of primary aromatic amine. Remember, it is the primary aromatic amine. IUPAC name is benzenamine. So with this, we finish the nomenclature. So IUPAC name and common name of the wherever I have marked the star is very important. Let us look into the preparation of each of this methylamine, ethylamine, and aniline. So we have to look into the three amines, three primary amines, that is methylamine, ethylamine, and the primary amines. So first we'll phenylamine. First we'll look into the methylamine first. So formula is CS3NS2, and remember there will be lone pair of electrons. So in the structure I have drawn the lone pair of electrons. The three hydrogen I have drawn in the skeletal of the methylamine, skeletal form. So laboratory preparation. Methylamine can be prepared by heating methyl iodide with the alcoholic ammonia in a sealed tube. So remember, methyl iodide is CS3I, then ammonia is HNS2 is an ammonia. Okay, I have just branched one hydrogen so that it will be suitable for us to remove the hydrogen iodide here. You can see. So hydrogen is red in color. I have also used different colors. So I have used different color so that it will be suitable for you to understand as well. So hydrogen from the ammonia, iodine from the methyl iodide will combine to form the hydrogen iodide. Remaining methyl and the amine, methyl and the amine are going to combine to form the methylamine. So you can see the black color of the methyl, red color of the amine. So methylamine. Even in the naming also I have used different color. Now the purpose of using alcohol, the alcohol is your ethyl alcohol. The purpose of using alcohol is to absorb hydrogen iodide. This hydrogen iodide can be absorbed by the alcohol. So when the hydrogen iodide is absorbed by alcohol, it will prevent the reverse reaction. Otherwise, if the hydrogen iodide is not removed, it will react with the methylamine. It will react with the methylamine and form the reactants. So that is the purpose of using the alcohol. Then in the note part you can see when an alkyl halide, any alkyl halide, methyl halide, methyl iodide, methyl chloride, ethyl chloride, any alkyl halide, when it reacts with the alcoholic ammonia in a sealed tube, the product form will be mixture of primary, secondary and tertiary amine. So even in this case also it will form, there are two hydrogen, again one hydrogen can be replaced by the alkyl group, again one more hydrogen can be replaced and it can give rise to primary and the secondary and the tertiary amines. Next point, primary amines may be obtained in good yield. Maybe the production will be high if we use excess ammonia. So primary amines may be obtained in good yield by using excess ammonia. Let us look into the physical physical properties of the methyl amine. They are colorless gas or liquid. They can be both form, gas or liquid form. with the fishy ammonical smell. So they will have a pungent smell, and they are soluble in water and organic solvent. The methylamine is soluble in water mainly due to the formation of intermolecular hydrogen bonding. So you can see this methylamine is forming an intermolecular hydrogen bonding with the molecule of water. So as soon as you put the methylamine into the water, it will form the intermolecular hydrogen bonding, which makes the methylamine soluble in water. So remember, methylamine solubility is due to the formation of intermolecular hydrogen bonding. Then you have the chemical properties. So we'll look into the basic nature of the methylamine. So methylamine is basic in nature due to the presence of lone pair of electrons. So lone pair of electrons in the nitrogen plays a very important role in giving the basic nature to the methylamine. Uh, because it can donate the lone pair of electron, the methylamine is also known as the Lewis base. In Lewis base, according to Lewis concept, base is a substance which can donate the lone pair of electrons. Acid is a substance which can accept the lone pair of electrons. So therefore, since methylamine is donating the lone pair of electron, therefore methylamine can also be considered as Lewis base. Now if we talk about the strength of base, whether the base is a strong base or a weak base, it depends on how easily it is donating the lone pair of electron to accept the proton. If the base is having a greater tendency to easily donate lone pair of electrons, then it can be considered as a strong base. And then if a base is having a less tendency to donate the lone pair of electron, then that particular base can be considered as a weaker base. Stronger base having a greater tendency to donate the lone pair of electrons, weaker base having a lesser tendency to donate the lone pair of electrons. The concept is going to be more clear if you look at these two substances, methylamine and the ammonia. If you look at the methylamine, methylamine has the methyl group, that is the alkyl group. The alkyl group has a ability to donate the electrons. So they are also known as electron donating group. So methyl I have also drawn with the red arrow head pointing towards the nitrogen, indicating that electron is being donated by the methyl group towards the nitrogen. So when the electron is donated by the methyl group to the nitrogen continuously, what happens is that in the nitrogen, the density of electron increases. There will be more electron in the nitrogen, thereby making the lone pair. You see the lone pair of electrons here. This lone pair of electrons will become more available for donation, thereby rendering methylamine to be more basic in nature. And then if you look at the ammonia, there are all three hydrogen present, no alkyl group, no electronegative element here attached to it. So therefore this lone pair of electrons is donated without the help of electron donating group. So in ammonia there is no alkyl group attached to it. It has all the three hydrogen. Therefore the lone pair of electrons will be, if you compare with methylamine, will be less available than methylamine. So therefore we can say that methylamine is more basic in nature than ammonia, because in methylamine there is an electron donating group which increases the density of the electron in the nitrogen, making the lone pair of electrons to be more available for donation. So in the exam also you will be asked methylamine and ammonia which is more basic in nature, or you will be asked compare the basic strength of methylamine and ammonia. So If you compare the basic strength, I have also given the statement below their answer. If you compare the basic strength of methylamine and ammonia, then methylamine will be more basic than ammonia. Due to the presence of electron donating group, it has a greater tendency to donate the lone pair of electrons to accept the proton. So this diagram will really help you to understand the concept of basic nature of the amines. Now let us look into the reaction of methylamine with water. So amines are more basic than water. Obviously, it will be more basic than water and gets protonated by it. That means it will take the proton of the water, hydrogen ion of the water, so gets protonated by it. It will abstract a proton from water and form the alkyl substituted ammonium ions and hydroxide ions. So let us look into the reaction. The reaction will help you to understand what will happen when the methylamine is reacting with the water. So obviously in the methylamine there is a lone pair of electrons, there is an alkyl donating group which will help you to donate the electrons towards the nitrogen. So this lone pair of electrons becomes more available for donation to the proton. So from water, this is the S2O is your water. Here also I have used different color. So S2O is water. So I have in the above I have written in the ionic form. This is water only. Okay, I am just representing this water molecule in the ionic form above for the for the for you for me to show the reaction clearly. So this lone pair of electron will be donated because it is acting as a base. It will be donated to the proton. So this proton will be abstracted. It will be taken by the nitrogen. So therefore, in after donating the lone pair of electron, this hydrogen, one of the there is only two hydrogen in the nitrogen. This hydrogen will be added. Now you can see there are three hydrogen, and there is a plus charge indicating that nitrogen has lost the lone pair of electron. Now remaining will be OH negative ion. So it is a positive ion here, negative ion. They can combine together to form methyl ammonium hydroxide also, or simply we can also write methyl ammonium ion is this one, hydroxide ion is this one, or together we can say it is methyl ammonium hydroxide. Okay, now we will see the reaction of methylamine with acid. Important. Since amines are basic in nature, they can easily react with the mineral acids like hydrochloric acid, sulfuric acid, nitric acid, etc. to form salts. They form salts. So remember, they form salts. In the methyl group, you can see there is a lone pair of electron. So this structure is very important to remember with the lone pair of electrons. Hydrochloric acid, in the above, I have written in the ionic form so that it will help you to understand the reaction in a better manner. The lone pair of electron will be donated to the proton. The proton will be abstracted, will be taken by the methylamine. So you can see initially they have only two hydrogen. With the hydrogen that is abstracted from the hydrochloric acid, there are three hydrogen now. The nitrogen develops a positive charge indicating that it has lost the lone pair of electron. Then the chloride ion here. So two together is methyl ammonium chloride, which is a salt. Okay, so there is an activity question for you. There is an activity question for you, activity 1. The activity 1 question is asking you to react methylamine with sulfuric acid to get the corresponding salt, that is the methyl ammonium bisulfate. So you will do this activity question in your notebook when you are copying the notes. So with this we finish the methylamine. Now next topic is your ethylamine. So if you have understood the methylamine nicely, then it will help you to understand the ethylamine, because the reactions, chemical properties, physical properties are almost same. So now let us look into the ethylamine. Ethylamine, or also known as ethanamine. Ethanamine is the IUPAC name. Ethylamine is the common name. So I have written both here. You can also find in the table in the above introduction. Formula is C2H5NH2. Again, this nitrogen will be having the lone pair of electrons. So in the below structure, where I have drawn the structure of the ethylamine, you can see the lone pair of electrons, which will be more available if you compare between methylamine and the ethylamine about the lone pair donation. In the case of ethylamine, the lone pair will be donated more because you have the higher alkyl group here. Laboratory preparation. This is very important from exam point of view. Many a times Mendes reaction has come in the exam also to write the reaction as well. So in Mendes reaction, ethylamine is prepared by reduction. By reduction of what? By reduction of methyl cyanide. So remember, ethylamine is prepared by reduction of methyl cyanide, or also known as ethane nitrile, with lithium aluminum hydride. Lithium aluminum hydride is a reducing agent, or sodium with the alcohol, or hydrogen in the presence of Raney nickel to give the primary amine, that is the ethylamine. So remember this explanation about the Mendes reaction, in which the methyl cyanide is undergoing reduction with lithium aluminum hydride, or sodium in the alcohol, or hydrogen in the presence of Raney nickel. In your textbook also you will find this reaction. So CS3CN is your methyl cyanide. CN is cyanide, so methyl cyanide. So there are 4 molecules of hydrogen. 2 into 2 is 4. So in both the side, I have, to make you understand better, I have written the hydrogen separately, indicating the 4 hydrogen here. So this 2 into 2 4 hydrogen, and this 4 hydrogen is same. Okay, this I have just extended to make the reaction clear for you all. So you can see this 2 hydrogen will be combining with the carbon, and the 2 hydrogen will be combining with the nitrogen, undergoing a reduction reaction. What is reduction reaction? Reduction reaction is the addition of hydrogen. So we are just adding the hydrogen to the carbon, we are just adding the hydrogen to the nitrogen in the presence of lithium aluminum hydride or sodium in the ethanol. So you can see I have used different color, so therefore you can see CH3C in between in between carbon and nitrogen, the 2 hydrogen is added, forming CH3CH2. Then NH, then 2 hydrogen added to the nitrogen, NH2, CH3CH2 NH2. Or it can also be written as there are 2 carbon, so C2, 3 and 2 hydrogen will be 5 hydrogen, C2H5NH2. You can either write the formula of ethylamine in this manner or in this condensed manner. So let us look into the physical property, almost same. You can see if you look at the physical properties of the methylamine and if you compare with the ethylamine, they are same, colorless gas or liquid with fishy ammoniacal smell, and they will be soluble in water and organic solvent. Solubility in water is due to the formation of intermolecular hydrogen bonding, but it will be less soluble. If you compare the solubility of methylamine and ethylamine, ethylamine will be less soluble in the water compared to the methylamine. You can see between the hydrogen atom of the nitrogen or of the ethylamine and the oxygen, there is a formation of a bond known as the intermolecular hydrogen bond, and this is the one which is responsible for making the ethylamine to get soluble in water. Chemical properties. Basic nature of ethylamine. Ethylamine is basic in nature. mainly due to the presence of lone pair of electrons in the nitrogen atom. Same like in the case of methylamine. Methylamine is also basic in nature. So basic in nature of methylamine, ethylamine is mainly due to the presence of lone pair of electrons. So remember the lone pair of electrons. So lone pair of electron is playing a very important role in defining the basic nature of the amines. So it will also be considered as a Lewis base because it can donate the lone pair of electrons. If you compare between the ethylamine and methylamine, earlier also I have told you the ethylamine can donate the lone pair of electrons more easily than the methylamine because it has the higher alkyl group. That means higher the alkyl group, easy will be the donation of the lone pair of electrons. So there is an activity question here. Compare the basic strength of the ethylamine and ammonia. So you have to find out ammonia is more basic in nature or ethylamine is more basic in nature, and then compare the basic strength of methylamine and ethylamine. Arrange the activity question 2, 3. Arrange the following compounds in order of the increasing basic strength. So ammonia, ethylamine and methylamine is given to you. So you have to arrange them in the increasing basic strength. Next is the reaction of ethylamine with water. So same above also you have earlier also you have studied about the reaction of methylamine with water. So if you know the above reaction, it will be very easy for you to understand the same reaction happening with the ethylamine. In this case, you just have to write ethyl group here in the place of methyl group. Reaction is same. So the lone pair of electrons will be more available for donation. So it will be donated to the proton of the water molecules. The proton will be abstracted. There are only two hydrogen here. After that, the product will be formed. You can see the three hydrogen here now with a positive charge on the nitrogen, indicating that it has lost the lone pair of electron, and then OH negative ion here. So it will be named as ethyl. Together it can form a ethyl ammonium hydroxide, or separately we can write ethyl ammonium ion hydroxide ion. So both will be accepted even for the case of methylamine also. Next, reaction of ethylamine with acid. Again, if you have understood the reaction of methylamine with the acid in the earlier lesson, then it is very easy here. All the reactions are same, except that you have to change the methyl group to ethyl group here. So we already know that amines are basic in nature, and when they react with the mineral acids such as the hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, they have the tendency to form the salts. So remember, when the amines react with the acid, they form the salts. So you can see the lone pair of electron is again donated to the from hydrochloric acid. You can see I have just evaporated in the ionic form. The lone pair of electron is donated to the proton. Proton will be abstracted. It will be taken, and you can see C2H5NH3 nitrogen with the positive charge, indicating the loss of lone pair of electron. Then chloride ion. So the name of the salt is ethyl ammonium chloride. There's an activity question again for you. In the above also I have given one activity questions. So react. In this case, you have to react ethylamine with sulfuric acid to get the corresponding salt ethyl ammonium bisulfate. Above one, in the case of methylamine, you have to react methylamine with sulfuric acid to get the corresponding salt methyl ammonium bisulfate. Here it is ethyl ammonium bisulfate. So if you could write the reaction for methylamine, you can also easily write the reaction for ethylamine for same. Now we have the last one, that is the aniline or phenylamine, also known as benzenamine, the IUPAC name. The formula is C6H5NH2. We'll shift to the next page together. It will be easy. So the formula can be written as C6H5NH2 Or you can write the structure C6H5NH2 with the nitrogen with the lone pair of electron, or you can simply write the C6H5 indicates the aromatic ring. The smaller ring inside indicates the alternate double bond present between the carbon, and then you have the lone pair of electrons. Let us look into the laboratory preparation. Aniline is most important aromatic amine. Among the aromatic amine, aniline is most important. So it can be prepared by the reduction of nitrobenzene. So remember, it can be prepared by reduction of nitrobenzene. The formula I have given here with tin. The formula of tin is Sn, or with iron. The symbol, not formula, symbol of iron is Fe in hydrochloric acid solution. So reduction of nitrobenzene with the tin or iron in hydrochloric acid solution. So here also I have used the different color to make you understand in a better way. So there is altogether 6 hydrogen, 3 to the 6 hydrogen. So I have drawn 1, 2, 3, 4, 5, 6. So these 3 molecules of hydrogen I have dissociated separately into hydrogens to make the reaction more clear for you. The 2 hydrogens will be directly added to the nitrogen, thereby giving you C6H5NH2. You can see C6H5NH2. Okay. And this nitrogen is black in color. It has gone red. So you can this nitrogen is directly from nitrobenzene. Okay. Only hydrogen is red in color because red hydrogen is added here. But there is no as such red and black. I am just helping you to differentiate it, understand the reaction better. Then remaining you have 4 molecules of hydrogen. 4 molecules of hydrogen will combine with the oxygen. Each of these 2 molecules will take one oxygen. If it takes 1 oxygen, it will form water. 1 oxygen, it will form water. So 2 together will form the 2 molecules of water here. So when the nitrobenzene is undergoing reduction in the presence of iron or tin in hydrochloric acid solution, it will give you aniline and 2 molecules of water. Or sometimes, since it is aromatic amine, you might be asked to write the reaction in the form of ring-like structure. So I have also written the ring-like structure formula here. You can see this represents C6H5NO2. So similar, if you know the above reaction, it will be easy. The 2 hydrogen will be added to nitrogen. So 2 together will form the NH2. This is the aniline. The remaining 2 hydrogen will combine with the oxygen to form the 2 molecules of water. So this reaction and above reaction is same. Only the difference is that this is nitrobenzene is in the form of ring-like structure. Physical properties. Now physical properties will be quite different compared with the methylamine and ethylamine. In the physical properties, you can see pure aniline is a colorless, oily liquid. But if you keep this pure aniline exposed to the air, okay, if it gets exposed to the air for a very long period of time, then it will, in the presence of air and light, then it will rapidly darkens, change into brown color. Some books it has written pale color, so rapidly darkens due to oxidation. It has a faint characteristic smell, light characteristic smell, insoluble in water but readily dissolves, insoluble or sparingly soluble in water, but it will be easily getting dissolved in organic solvents like ether, benzene, alcohol, etc. And they are also toxic in nature. Now aniline is insoluble in water or sparingly soluble in water because the large hydrocarbon, that is the ring-like structure that you have seen, part C6H5 is the large hydrocarbon part, okay, which prevents the formation of intermolecular hydrogen bond. So if the alkyl group becomes very bulky, and that bulky alkyl group will prevent the formation of intermolecular hydrogen bonding. thereby preventing the aniline to get dissolved in the water. So chemical properties now. So basic nature of aniline. Now if you compare the basic nature of aniline, aniline is a very weak base, weaker than the ammonia and weaker than the aliphatic amines like methylamine and ethylamine. So its weaker nature is because the lone pair of electrons, that do you see the lone pair of electrons? This lone pair of electrons that is present on the nitrogen is not easily available because they are undergoing delocalization. This lone pair of electrons will fall here and form a double bond. Nitrogen will have a positive charge indicating the nitrogen has lost the lone pair of electron. So when the lone pair drops down here, this double bond will be shifted here. So lone pair will be shifted here, and then again it will be shifted here in the third resonance structure. Then in the fourth resonance structure it will be shifted on this carbon. Every corner in this hexagonal shape is the carbon. Okay, this is not simply the ring. This is one carbon here, one carbon here, one carbon here, one carbon. So total you have six carbon with each hydrogen. This carbon will not have the hydrogen. So you can see in each of this resonance structure the lone pair is getting delocalized. It is moving from one carbon to another carbon. So in thereby what is happening is the lone pair of electron will be less available for donation to proton. So earlier we have discussed that if the tendency to donate the lone pair of electron is less, then it is going to be weaker base. Okay, so that is the main reason why the aniline is a weaker base. So this is an important part. Okay, you don't have to remember this resonance structure. This resonance structure is given to simply understand how this lone pair of electron is moving from one point to the another point, making it unavailable for the donation. So if the lone pair cannot be donated easily to the proton, then that particular amines will be considered as a weaker base. Activity question is there. Arrange the following compounds in order of their increasing basic strength. So you have the ammonia, you have the ethylamine, you have the methylamine, and then you have the aniline. So you have to arrange these, study them nicely, okay, understand them nicely, and then arrange them in their increasing basic strength. Reaction of aniline with water. If you have remembered the reaction of methylamine with water or ethylamine with water, it will be very easy for you to understand the reaction of aniline with the water. So the lone pair of electrons that is present on the nitrogen will be donated to the proton. Obviously, it will be a less donation compared to the methylamine and ethylamine. However, it will be donated only because that lone pair has to be donated, and that is the main reason why aniline is acting like a base. So it is donated, hydrogen is abstracted. You can see earlier you have only two hydrogen in the aniline. Now you have the three hydrogen. So C6H5NH3 plus and OH negative ion, two together can be considered as phenylammonium hydroxide. Separately they can be written as phenylammonium ion or hydroxide ion. Reaction with the acid. So when amines reacts with the acid, they are going to form the salt. So amines are basic in nature and reacts with mineral acids such as the hydrochloric acid, sulfuric acid to form salt. So remember, when the amines, any amines, whether methylamine or ethylamine or the aniline, when they react with the acid, they form the salt. So if you remember the above reaction of the methylamine and ethylamine with the hydrochloric acid, very easy to understand the aniline here again. It is just the replication of the above reaction only. Just we have to uh, remove the methyl group or ethyl group and add the C6H5. Lone pair of electrons will be donated to the proton. So hydrochloric acid above I have written in the ionic form. It is the same one I'm writing in the above to make it more clear to understand. So H plus ion will be taken. Nitrogen will develop a positive charge indicating the losing of lone pair of electron. Initially there were 2 hydrogen in the nitrogen. Now you have the 3 hydrogen with the chloride ion. Together we can call it as phenyl ammonium chloride, which is a salt. There is an activity question again. React aniline with sulfuric acid to get the corresponding salt, phenyl ammonium bisulfate. So earlier also you have the same activity for the methylamine and the ethylamine, and you have the same activity with the aniline. So if you have understood the above two reactions, this reaction can also be written easily. Now this carbolamine test, also important, but it is not mentioned in the prioritized curriculum that is given to you, but it is important. Carbolamine is important test. It is the test that can be used to distinguish between the primary amine from the secondary amine and tertiary amine. So you can differentiate whether it is a primary amine or a secondary amine or tertiary amine by using the carbolamine test. In this test, when the aniline is warm, because aniline is a primary amine, earlier also I have told you, okay, C6H5NH2, because there are 2 hydrogen, only 1 hydrogen is replaced by C6H5. So in this test, when aniline is warmed, aniline, which is the primary amine, is warmed with the chloroform. So remember the two substances, chloroform and alcoholic caustic potash. Caustic potash means KOH. Is the formula KOH. It produces phenyl isocyanate. So remember the product also, phenyl isocyanate, which gives an offensive smell. So once again, in the carbolamine test, when the aniline is warmed with the chloroform and the alcoholic caustic potash, it produces phenyl isocyanate, which gives an offensive smell. If you don't want to write alcoholic caustic potash, you can simply write potassium hydroxide. This is the general reaction. This is your aniline reacting with the chloroform and the alcoholic potash to form the phenyl isocyanate, which gives an offensive smell, and then 3 molecules of potassium chloride and 3 molecules of water. Now this reaction will give you the idea how this product is formed. So let us look into this one. This reaction same. I'm just writing in this form to let you understand how the products are formed. Because if you know this way of writing, you don't have to memorize all this. You simply have to memorize the reactants, and if you know this one, you can simply form the product. So let us see. C6H5NH2. So there are 2 hydrogen. I have splitted the 2 hydrogen. CHCl3, there are 3 chlorine. I have splitted the 3 chlorine, 1 carbon, 1 hydrogen separately. Then there are 3 molecules of potassium hydroxide. So 3 potassium means 3K, 3 potassium, 3 oxygen, 3 hydrogen. So 3 potassium I have split it above, 3 oxygen below, 3 hydrogen below. Okay, now these 3 molecules of chlorine and the potassium 3 together will react to form the 3KCl, that is potassium chloride. Next, the hydrogen, you can see the 2 hydrogen from the aniline, 1 hydrogen from the chloroform, and the 3 hydrogen from the potassium hydroxide, and the 3 oxygen. Each of this, they will form 1 molecule of water. This hydrogen, this oxygen, and this hydrogen form 2 molecule of water. This hydrogen, this oxygen, this hydrogen will form 3 molecule of water. So you have 3 molecule of water. Then you have the carbon now from the chloroform. This carbon will be added directly to the nitrogen. So therefore you will have C6H5NC, which is the phenyl isocyanate. So this is your phenyl isocyanate, 3 potassium chloride, then 3 molecules of water. So look at this reaction, how I have written. If you have understood, you just have to remember all this. then you can easily write the product. So there is an activity question again. Write the carbolamine test reaction in which aniline is warm with chloroform and alcoholic caustic soda. The alcoholic caustic soda is your sodium hydroxide. So you are in the place of KOH, you are going to use 3NaOH. Then write the carbolamine test reaction in which ethylamine. Now you have to use ethylamine, warm up with the chloroform and alcoholic caustic soda. Because ethylamine is also a primary amine, it can also undergo a carbolamine test. Again, write the carbolamine test reaction in which the methylamine is warm with the chloroform and alcoholic potash. Methylamine is also a primary amine. It can also undergo a carbolamine test. So write for methylamine and ethylamine. Then by Hofmann's bromide reaction, primary amines can also be obtained. We can also get the primary amine. We can also get the primary amine from primary amides by Hofmann's bromide reaction. There is a reaction known as Hofmann's bromide reaction. Very famous reaction, frequently coming in the exam also. So when you react the primary amine, when you react the primary amide with the bromine and the 4 molecules of potassium hydroxide, the whole reaction is known as the Hofmann's bromide reaction. This method consists of treating a primary amine containing 1 carbon atom less. It is 1 carbon atom, okay? 1 carbon atom less than amide is obtained. Okay, so if you look at this one, you have, this is your amide, CH3CONS2 amide, okay, ethane amide. So this is primary amine is methylamine is primary amine is here. This is wrong. I have written in the bracket primary amine. It is not. So you just erase this one and shift this bracket here. Methylamine is the primary amine. Now if you compare ethanamide with the methylamine, in the methylamine you have only 1 carbon. In the ethylamide you have 2 carbons. So if you compare to primary amine, methylamine contains 1 carbon less. So in the primary amine, methylamine contains 1 carbon less. So that is what it is written here. This method consists of treating a primary amine containing 1 carbon atom less than amide is obtained. So in this reaction you can see CH3CONS2 Br2, so 2 bromine molecules. So I have written separately, split them into 2 bromine molecules. 4 potassium, so 1 2 3 4 potassium, there will be 4 oxygen, 1 2 3 4 oxygen, there will be 4 hydrogen, 1 2 3 4 hydrogen. So 2 bromine molecule and the 2 potassium molecule will combine to form the 2 KBr. Then this hydrogen combined with oxygen to form the water molecule. This hydrogen combined with this oxygen to form the water molecule. So 2 molecules of water. Then after that, this CO will be taken by the 2 molecules, 2 atoms of potassium and 2 atoms of oxygen to form K2C. There are 3 oxygen, CO3. So K2CO3 is obtained by taking this one. Remaining is CH3NS2, which is the primary amine. Now just little bit differentiate between the aliphatic amines and the aromatic amines. Colorless gas or liquid is a colorless liquid which turns brown on exposure to air. Soluble in water, insoluble or sparingly soluble in water is the aromatic amine. No delocalized pi electron here. Delocalization of pi electron happens. You have seen earlier structure. Delocalization of pi electrons is this one. Delocalization of pi electrons happens in the aromatic amines. Then gives carbolamine test. Even this aromatic amine also gives the carbolamine test. 2008 question. There is a 2008 question. Okay. And the 2008 question is there. Then you have the 2011 question, 2012 question, 2017 question is there, 2018 question is there, and 2019 you can search the question related to amines and solve it. So with this we finish the amines. Have a good day. Enjoy the lockdown. Thank you.